Hi, it's Miss Andrews and Miss Conley again, and here's our exponent laws part 2 of our mixed review. So in this problem here we have one big fraction or one big division problem. So we want to think about first reducing our fraction if we can, meaning reducing the coefficient part, the numbers. So negative 2/8 can become negative 1/4, and then we can go through and look at our different variables and use our exponent laws there. So we have an x to the first power and an x to the first power, so they're the same values. That means really that they're reducing each other out or canceling each other out to a value of 1. We don't have any x's remaining. And with the y's, we had more y's in the denominator, so when we subtract 5 minus 2 to get 3, that answer needs to be written in the denominator because that's where we had more y values. And the z's need to go in the top because we started with 4, we had more in the numerator.
And when do we know to subtract the exponents?
When we have a division problem with the same base, then we can subtract the exponents to get our value.
Okay.
And there's one more step that we can do to make this answer a little bit better. What do you think we should do there, Miss Conley?
I think that negative 1, we don't need to write the 1 if that's the coefficient, but we do need the negative sign.
Perfect. All right, so we get negative z to the second power over 4y to the third.
Okay, so this problem, there's a couple different ways of doing this. We can either distribute that exponent, the square that's outside of the brackets first, and then simplify, or we can simplify what's inside the brackets first and then share the exponent. So what do you think?
Well, I think it's always better to reduce that fraction or simplify it first because we don't want to end up with numbers that are really large and not recognize that they can still be simplified.
Okay, so let's leave our squared outside of the brackets and we'll simplify inside the brackets first, doing the division there. So our coefficients, we have 3 over 6, which we can reduce to 1/2. Notice that's a to the first power in the numerator, divided by a cubed. So we're going to subtract the exponents because we're dividing, but we need to put the a squared that's left in the denominator because we started out with more a's in the denominator. Okay, so now we need to share this squared with everything inside of the brackets, including the 1, the 2, and the a squared. So we have 1 squared in the numerator over 2 squared a to the 4th, because when we raise a power to another power, we multiply the exponents. Okay, 1 squared means 1 times 1, so that's 1. 2 squared is 4, and then a to the 4th. Now in this case, we do need to write the 1 because there's nothing else left in the numerator with the 1, so it needs to be there.
Okay, again, our last one, we have a fraction raised to a power. So here's one where we definitely want to reduce that fraction before we start raising things to the third power. Like 16 to the third power is going to be quite a large number. So let's put those brackets in there. And we're going to leave our cubed out. 8/16 can be reduced to 1/2. And then we have x to the third and x to the first power, so 3 minus 1 gives us x to the second in our numerator. And y to the fifth and y to the 8 leaves us y to the third in our denominator. Now we can go through and share that exponent with everything that's inside. Our little spider web here, there we go. 1 to the third power and x to the 6th because we're multiplying 2 times 3. 2 to the third power and y to the 9th because we're multiplying 3 times 3. We still want to go through and multiply out our numerical values to see if we can reduce our fraction. So 1 to the third power means 1 times 1 times 1, which is still giving us just 1, x to the 6th. And 2 to the third power, remember, it doesn't mean 2 times 3, it means 2 times itself 3 times. So we need 2 times 2 times 2, which gives us 8, y to the 9th.
Okay, why can't we simplify those bases anymore, the x and the y?
In order to simplify and reduce our fraction, even though it's division here, they have to be the same base, and we have 2 different variables here, so they don't have the same base. So we're not going to just look at those and subtract our exponents anymore.
Got it.
We still do have one more thing that we can do to make this the best solution, and that's to leave off the 1 because when we have a variable without a coefficient, it's an understood one, and so it's a bit repetitive to have the 1 and our x to the 6th.